Good morning, class. Statistics practice test number 3, module 3, covering chapter 6 and 7. Here's chapter 6, normal probability distribution, part 2. Here's the pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. We've seen this before. I hope everybody pays attention to that. Of course, we can use formula sheet tables and a graphing calculator as far as statistics is concerned. So having said that, let's continue. We are looking at question number 6. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. What percentage of people has an IQ score above 120? So first and foremost, any application, what is given symbolically, the mean is mu equals 100 and standard deviation is sigma because we are dealing with the population. And so above 100, we want the probability of X larger than 120. That's understanding this. Having said that, we're going to go with the z-score, which is X minus mu over sigma. And we have mu, we have sigma, and X is 120. Keep plugging. And at this point, you can use calculators, any other, the Excel file, you name it, anything that you can use, but z-table will give you the answer by noticing it's beyond, this is 1.33 and beyond that. So definitely less than 0.5, we should mention that. So about 9.18%. What is the maximum IQ score for the bottom 30%? So let's locate the bottom 30% is this. That means the area is 0.3. So first we want to find the z-score. Okay. So to find the z-score, you can go with the table, you can go with the technology. The table gives you a number somewhere in between. And z is X minus mu over sigma. If you do the cross product, that I'm going to assume nobody is going to have a problem with that, X becomes mu plus z sigma. And mu is 100. Z is somewhere in between. Let's go with negative 0.525 and times sigma, which is 15. And we get this. So maximum IQ score for the bottom 30% is 92.125. Technology, inverse normal distribution. Area is 0.3, mu is 100, sigma is 15. And it gives you the answer in one shot. But again, you really have to understand it comes from here. So writing the formula helps because it's telling the reader, what you're doing. And even if it's wrong, we can get some partial credit. So having said that, here's number 7. Men have head breadths that are normally distributed with a mean of 6 and a standard deviation of 1. If a man is randomly selected, find the probability that his head breadth is less than 6.2. So first and foremost, what is given? Normal distribution, or ND, mu is 6 and sigma is 1. That's the first. Now, it's important to know we are dealing with how many subjects? Just one subject. N equals 1. We want probability of X less than 6.2. With N being 1, we are going to use the Z equals X minus mu over sigma. Six point two minus 6 over 1 is 0.2. Probability of Z less than 0.2. Let's go with the graph. I really highly recommend you come up with the graph. So 0.2 is somewhere here. So that means we want this area. And the reason it helps because You should recognize whatever it is has to be larger than 0.5 because half and half on each side, okay? So we get 0.5793 from the table. If we look at the same situation, but this one, if 100 men are randomly selected, find the probability that their head breadth is less than 6.2. Now, the difference is here. If everything is the same, n is 100. And because n is 100, we want probability of x bar less than 6.2. So x bar minus mu of x bar over sigma of x bar, where mu of x bar and mu are identical. However, sigma of x bar is sigma over square root of n. So 6.2 minus 6, exactly the same numerator. But the denominator is 1 over square root of 100, and that makes a huge difference. Instead of 0.2, we are dealing with 2, and probability of z less than 2, 2 is here. That means now this area, which is much more. And we get 0.9772. If we go with the technology for this one, lower. This is what they use, okay, but as I mentioned, this is really negative infinity. So 1e99, that means you're dealing with a scientific notation, and this is, it's hard to see that it's negative, okay? Negative 1e99, that means times 10 to the power of 99 on the negative side. Upper is 6.2, mu sigma, sigma equals 1. But you could use minus 100, minus 1000. It gives you really the same result. As you can see, those are the answers. And for this one, use the same thing. The difference is the sigma. So when you compare these two, the difference is sigma. Sigma of x bar is sigma over square root of n. And that's why you have a different answer here. So I hope everybody is okay with that. We're going to move on. Okay. The assets in billions of dollars of the four wealthiest people in a particular country is this. 33, 29, 16, 11. Millions or billions, but assume that sample of size n equals to are randomly selected with replacement from this population of 4. So we have 4 and we pick 2. So after identifying the 16, 2 to the power of 4 different possible samples, and finding the mean of each sample, construct a table representing the sampling distribution of a sample means. We want to actually discuss mu of x bar, which becomes the same as mu. That's the idea. So having said that, when you choose 2 and it's with replacement, then you get 2 to the power of 4 items. Here's what you get. 33 with itself, with 29, with 16, with 11. Then you move on to number 29. 29 with 33, 29 with 29, 29 with 16, 29 with 11. Then you move on to the next one. You continue. So I've shown the first 8 and how you arrive at it. So for example, 16 with 33, with 29, with itself, with 11, then 11 with 33, with 29, with 16, with itself. Okay. So obviously 33 and 33, the average is itself and it's 1 out of 16. The same thing with 29 and 29, the average is itself 1 out of 16 and so on. But 33 and 29, the average is 31. This is 1 over 16, but bear in mind, the average of 33 and 29 is the same as the average of 29 and 33. So that's why for this one, we end up with 1 over 16, and 1 over 16 is 2 over 16. So when the average is one of the numbers, we get 1 out of 16. But if it's any other one, it's 2 out of 16. So we get the following. When the average is 33, 1 out of 16. So here's the X bar, here's the P of X bar, okay? So this is the sampling distribution of the sample means. I want to make sure everybody understands the wording. This is the sampling distribution for what? For X bar, sampling distribution of the sample mean, X bar. Sample means X bar. So 33 is 1 over 16, but 31 is 2 over 16. Okay, because again, there are two possibilities. Same thing happens with the rest of it. 29, 1 out of 16, but 24.5, 2 out of 16, so on and so on. So that's understanding the sampling distribution. So again, this one, 1 out of 16, but this two, 2 out of 16. So I want to make sure we understand how we arrive at them. So having said that, compare the mean of the population to the mean of the sampling distribution. The mean of population is very simple. Mu is summation of X over N, add them up, divide by 4. So that's the actual mean for those 4 pieces. This is the mean of the population. What about the mean of the sampling distribution? I hope you remember, would be X bar P of X bar summation. So I hope you remember this formula. Mu is summation of X P of X. Therefore, mu of X bar is summation of X bar P of X. So multiply this one then times this one, plus this one times this one, all the way to the last one. And we get absolutely the same thing. It's very straightforward. I hope everybody's okay with that. And as you can see, they are equal. And that's the idea. So do the sample means target the value of the population mean? In general, do sample means make good estimates of population means? Why or why not? The sample means target the value of the population. That is, the mean of the sample means, the expected value of the sample mean, is equal to the population mean. That is the meaning of targeting. Okay, everybody? The population of current statistics students has ages with mean, mu, and standard deviation sigma. Samples of statistics students are randomly selected so that there are exactly 44 students in each sample. For each sample, the mean age is computed. What does the central limit theorem, CLT, tell us about the distribution of those mean ages? So let's discuss the CLT, short for the central limit theorem. The central limit theorem, a sampling distribution of a sample means, is the distribution obtained by using the means computed from random samples of a specific size taken from a population. For samples of size n larger than or equal to 30, the distributions of the sample means can be approximated reasonably well by a normal distribution. The approximation becomes closer to a normal distribution as the sample size n becomes larger. Conclusion. Number 1, the distribution of sample X bar will, as the sample size increase, approach a normal distribution. The mean of a sample means is the population mean. Mu of X bar is mu. We showed that in the previous page. The standard deviation of all sample means is sigma of X bar is sigma over square root of n is smaller. In this example, Since n is 44, which is larger than 30, a sampling distribution of the mean ages can be approximated by a normal distribution with mean mu of x bar is mu and standard deviation sigma of x bar is sigma over square root of n or sigma over square root of 44. A boat capsized and sank in a lake. Based on an assumption of a mean weight of 137 pounds, the boat was rated to carry 50 passengers, so that the load limit was 137 times 50 or 6,850 pounds. After the boat sank, the assumed mean weight of similar boats was changed from 137 to 170 pounds. Assume that a similar boat is loaded with 50 passengers, and assume that the weights of people are normally distributed with a mean of 174.1 pounds and a standard deviation of 35.1 pounds. Find the probability that the boat is overloaded because the 50 passengers have a mean weight greater than 137 pounds. So what are we dealing with? We are dealing with a normal distribution. N is 50, mu is 174.1, sigma equals 35.1. So first, let's write the given. Now the question is asking, find the probability. So probability that the boat is overloaded because the 50 passengers have a mean weight, probability of X bar larger than 137. So that's what we are going to calculate. So we're going to use the fact that z is X bar minus mu of X bar over sigma of X bar. And X bar is 137. Mu of X bar is equal to mu is 174.1. And sigma of X bar is sigma over square root of n. We're going to use that. The result is negative 7.474. And so probability of z larger than negative 7.4. As you know, if we go 3 standard deviations from the mean, 3 standard deviations to left and right, we cover 99.7%. So this goes to infinity. And this one is more than 3 standard deviations over on the left, 7 standard deviations on the left, 7.47. So you can see that clearly it's about 100%. So that's bad. The boat was later rated to carry only 15 passengers. And the load limit was changed to 2550 pounds, 170 times 15. Find the probability that the boat is overloaded because the mean weight of the passengers is greater than 170. So their total weight is greater than the maximum of 2550. So again, we are writing the information. The information is over here, identical. N has changed from 50 to 15. But we still want the same thing with the number 170. Probability of X bar larger than 137 here. Probability of X bar larger than 170 for part B. Again, we are going to go with this formula and evaluate the Z. 170 minus 174.1 over 35.1 over square root of N 15. And so we want Z of larger than this number. And clearly, it's somewhere here, and you use a calculator or the table. 0.6745, that's too much. Do the new ratings appear to be safe when the boat is loaded with 15 passengers? Absolutely not. No, because there is high probability of overloading. The new rating do not appear to be safe when the boat is loaded with 15 passengers. Absolutely not. At an airport, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 and 10 minutes. All of the different possible waiting times are equally likely. Find the probability that the randomly selected passenger has a waiting time of at least 7 minutes. So let's discuss something. Number one, what is a uniform distribution? A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. The graph of a uniform distribution results in a rectangular shape. Properties of uniform distribution. Density curve. The graph of any continuous probability distribution is called a density curve, and any density curve must satisfy the requirement that the total area under the curve is exactly 1. Because the total area under any density curve is equal to 1, there is a correspondence between area and probability. Therefore, probabilities can be found by identifying the corresponding areas in the graph using the formula for the area of a rectangle. Area equals height times the width. So the total area is 1 and the width is 10 because we're going to go from 0 to 10 minutes, and the height therefore must be 1 over 10. So along the number line from 0 to 10, okay, and the height must be 0.1. As you can see, the product of these two, the area is 1. Now, probability of wait time of at least 7 minutes, that means probability of x larger than or equal to 7. So you look at number 7. This is the area you want, obviously. The height, which is 0.1, times the width. The width is 3. I hope you see that from 7 to 10 is 3. And therefore, the product is 0.3 or 30%. Information regarding standardized tests used for college admittance scores on the SAT test are normally distributed with a mean of 984 and a standard deviation of 204. So for SAT, those are the information. Scores on ACT test are normally distributed with a mean of 20.7 and a standard deviation of 4.3. It is assumed that the two tests measure the same aptitude, but use different scales. So I hope everybody is clear as to what's going on here. If a student gets SAT score that is 65 percentile, find the actual SAT score, and they want us to round it. So let's write the information for this piece. Mu is 984, sigma is 204. For this one, mu is 20.7, sigma is 4.3. So we're using different colors to indicate what's going on. So SAT score 65 percentile. So that means the area is 0.65. And if the area to the left is 0.65, this point, what is the z-score for that? So let's find that. So the area to the left is 0.65. We are going to find the z-score, and after that, we can get to SAT. So first we find the z-score, and then SAT is the x value. So z is x minus mu over sigma. Cross product means x is mu plus z sigma. And having said that, we are dealing with SAT. So right here, mu and sigma come from here. So we are going to replace the mu, sigma, and Z. Now the question is, how do you find the Z? You have to find the Z either from the table or technology. So we have everything except Z here, everybody. So if you go with technology, inverse norm, area is 0.65, mu is 0, sigma is 1, and we end up with this number. And you really want to use a lot of decimals here. So what I did, I went with 4 decimals. And in this case, because we are going to round it to the whole number, wouldn't make that much of a difference. So 1062, and because of this, 1063, that's the answer, 1063. So a student at a 65 percentile has this score. And I hope you understand what's happening. 50th percentile would give you the exact value as the mu. Okay, that means in the middle. Just so 50% on the left, 50% on the right. So this means it's separating the bottom 65% from the top 35%. What would be the equivalent SAT score for this student? So we want to find the X value for this group, and we are going to use the same Z here that was calculated and find the X. And if Z is that, X is that. And so we got everything just to make sure mu and sigma come from this area. So we're going to write this mu and sigma we are going to use here. And the Z that we had here, plug in. And this one, how many decimals? 1 decimal. That's why we go with 2. We make a decision to change it to 22.4. The answer is 22.4. In other words, SAT score of 1063 is equivalent to ACT score of 22.4. That's the meaning of it. We've done. It's very straightforward. So to understand them, you go to Z-score. In both cases, the Z-scores are identical. That's the idea. If a student gets an SAT score of 1,494, what about the ACT score with 1 decimal? We go through the same process. You have to find the Z and take it from there. So in this case, X is given. It's similar to part A, X is given. So we want to find Z, and from the Z, we go to X of ACT. So Z is X minus mu over sigma, and 1494 minus mu and sigma from this area is 2.5. That's all we need, because the Z score is identical for both. And now, X is mu plus Z sigma, 31.45 to make it into 1 decimal. The answer is 31.5. So SAT score of 1,494 and ACT score of 31.5 are equivalent. A food marketing institute found that 35% of households spend about $150 a week on groceries. Assume the population proportion is 0.35 and a simple random sample of 300 households is selected from the population. What is the probability that the sample proportion P hat of households spending about $150 a week on groceries is less than 0.38? Okay. So we are dealing with what? We are dealing with a binomial distribution. N is 300 and P is 0.35. So given binomial distribution, proportion of a household is 0.35 that spends that much, with the sample that we discussed N is 300. So that's, you either spend 35%, you're among those 35% households or not. Okay. If P is 0.35, Q must be 1 minus that, 0.65. And clearly NP and NQ must be large, and they are. Okay. So we want the probability that P hat is less than 0.38. And to move on, we should really show NP and NQ is larger than 10. I hope you see if NP is clearly larger, two zeros is 3 times 35, 105. NQ is even larger. So what are the formulas? Mu of P hat is P, sigma of P hat is square root of PQ over A. Again, you can find the formulas, the formulation. So mu of P hat is P or 0.35. Sigma of P hat is PQ 0.35 times 0.65 divided by N 300 and take a root. That's what the two formulas tell us. This one is given, this one using a calculator, or without that, you can evaluate that. So probability of P hat larger than 0.38 is of interest to us. We can use technology, normal CDF, lower. Again, see, they give us this number. What it means is minus 1 times 10 to the power of 99. It's a huge negative number. But if it's not there, just put minus 1,000. Minus 1,000. It's important to understand that. Okay. The upper limit is 0.38. So just, in other words, let me just graph this. What we want, the upper is, this is not to scale, 0.38, and you want this one. So what do you put here? Instead of minus infinity, put minus 1,000. Okay, in case. Even minus 100 will do that. Again, because 3 standard deviations on both sides of the mean gives you almost everything 99.7%. 99.7%. So having said that, it gives you the answer. And there you have it. Now, let me erase my work. So it gives you this answer. If we want to go with the z-score, this was just using the information given. If you want to go with the z-score is x minus mu over sigma, or p hat minus p over sigma of p hat. So p hat is 0.38, p is 0.35, sigma of p hat is 0.027538. You get this one, and that is the z-score. So probability of p hat less than 0.38 or probability of z less than 1.0894. And if you go with the z-score, the standard normal distribution, obviously you get the same answer. Now I'm using 4 decimals. You have to use however many decimals that they ask you. The bottom line, there are 2 ways to do that. You can go this route and use mu and sigma with that, or change this to a z-score and go with standard normal distribution. According to a survey, 10% of Americans are afraid of flying. Suppose 1,100 Americans are sampled. What is the probability percentage that 121 or more Americans in the survey are afraid to fly? And there are different ways of approaching them. We're going to go with all those methods. So given a binomial distribution, P is 10%, N is 1,100. Why is it binomial? There are 2 outcomes. We are scared or not of flying. Okay. And it's independent, whether I'm scared or not, or you're scared or not, it's completely independent. So that's the given. So we're going to look at different methods. So 121 or more, x is 121. So p hat is x over n, 121 over 1100. That means 0.11. And a probability of p hat larger than or equal to 0.11. That's what we want. Okay. So if that is the case, mu of p hat is p sigma of p hat square root of pq over n. Just like the previous page, this one doesn't change. This one we have to put it into a calculator to get the sigma of p hat. This is the answer. And we can go with that. So lower is 0.11 because it's larger than or equal to 0.11. Upper. Now, because this is proportion, you can even, if you use 1000, it works, everybody. But why is it that 1 works? Remember, proportional probability goes between 0 and 1. That's why even 1. And on purpose, I have 1 here. I want to make sure everybody understands. And you paste it and you get the answer. Again, I want to make sure everybody understands you can use 1000 here. But the reason I'm using 1 because it's a proportion and I want to make a point of that. So that's what we get. Here's the second method. We calculate the z, x minus mu over sigma. In this case, p hat minus p over sigma of p hat. So what is p hat? 0.11. So 0.11 minus 0.1 over sigma of p hat, that is this number 0.009045. And here's what we get. So that is equivalent of probability of z larger than or equal to that. So it's the method 2. We also have method 3. As you recall, in the case of a binomial distribution, when x is larger than or equal to 121, we go with the continuity correction factor of 0.5. We either add 0.5 or subtract. If I add, now let me show you again. Probability of x larger than or equal to 121.5 or probability of x larger than 120.5. Which one? This one, the first discrete value would be 122. This one, the first discrete value would be 121. And because of the equality, we want 121. So this is out. Okay, I hope everybody understands what I've done. I'm going to erase my work. And now I need to find the z-score. Mu is np, sigma is square root of npq. So I need this information to put it in here and evaluate it. And z becomes 1.0553. Okay, which is exactly the same thing as this one, almost. Different z-scores because we are approximating binomial distribution by normal distribution or standard normal distribution. That's why we have slightly different answer. And you put that into a calculator. And as you can see, in all cases, we get the same thing within 4 decimals. They are the same. And remember, 4 changes to 5 because next to it is 6. Very straightforward. I hope everybody is okay with that. I just wanted you to be exposed to various methodologies that we can handle this. We're going to continue with the same question, part B. What is the probability percentage that 165 or more Americans in this study are afraid? So p hat is x over n, 165 over 1100 is 0.15. Probability of p hat larger than 0.15. And you can calculate the z-score. Okay. Using, of course, p hat minus p over the sigma of p hat. So probability of z larger than that's definitely 0 or very close to 0. Remember, from the mean, 3 standard deviations away on the left and right covers everything. So if it's 3 standard deviations on the right and it continues, this is way more than 3. That covers nothing. So lower is 0.15, upper is 1, mu is 0.1, sigma is this, paste it, lower it. And as you can see, the answer, look at this one. What does that mean? Times 10 to the power of minus 8. Let me actually write that. This means 1.626 times 10 to the power of minus 8. And that is almost 0, everybody. That's a scientific notation. What is the probability percentage that 8% or less of the Americans surveyed answered they were afraid to fly, rounded to 2 decimals? So having said that, we want the P of P hat less than 0.08 according to this. And we've already done a lot of calculations, so let's put it in. So less than 0.08, lower is 0. The reason you can use 0, you can use minus 100 or 1000 because we are dealing with proportion. Upper is 0.08, mu is 0.1, and sigma is 0.009045 I'm using those information, of course. Or you can go with normal CDF and use minus, I don't know, 10,000 or 1,000. Okay, doesn't make any difference. You get the following answer, which means 1.35% or 0.135 that has been changed accordingly.